Hello, this is Mr. Stansbury. I'm going to take you through the 7D notes on midpoints. So at the end of this, you should be able to say that I can find the coordinates of a midpoint of a line, and then also I can find the coordinates of an endpoint if I know the midpoint and the other endpoint. Alright, so let's start off with our midpoint formula, which is m for midpoint equals x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And if you think about that, that should hopefully make good sense, because it's basically just taking the average of the 2 points. So you add the 2 points together, divide by the number of points, which is 2, add the 2 y coordinates together, divide by 2, and you've found your average. Alright, so let's put that into use, and let's find the midpoint of AB if A is -1, 3, and B is 4 or 7. So all we're going to do on that here is just plug it into our formula. So M is, and we have, let's call this the first point, so we'll call this x1 and y1, and then this will be x2 and y2. Right? So when we plug that in, we get -1 plus 4 over 2, and then we also get 3 plus 7 over 2. Right? So midpoint is -1 plus 4 is 3 halves, and 3 plus 7 is 10 halves. So we get that our midpoint is, again, you can just leave that as 3 halves, or you can put 1.5, and then 10 divided by 2 is 5. So there's our midpoint of that line there. And this really should say, way up here, this really should say line segment, because, so let's change that. Okay, because you really can't find the midpoint of a line, because the line goes on forever and ever each way. So let's change that to line segment. Alright, so let's see, let's take a look at another example. And we got M is the midpoint of AB. So we're going to find the coordinates of B if A is 1, 3, and M is 4, 2. So there's a couple ways to do this. Let's see, one way is just plug it into the midpoint formula. Okay, so midpoint is, let's see, we actually know what the midpoint is, so we don't have to write M equals. We know that the midpoint is 4, 2. And that's going to equal the x plus the other x. So, let's see, let's do 1 plus the x that we don't know over 2, and then we've got 3 plus the y over 2. Alright, so we know that this 1 plus x over 2 has to equal the 4. So 1 plus x over 2 has to equal 4, and then we also know that the 3 plus y over 2, it's a plus there, 3 plus y over 2 should equal 2. Alright, so then you can just put both of these over 1, and you can just cross multiply, right? 1 times 1 plus x is 1 plus, that looks like 1xx. 1 plus x should equal 2 times 4, which is 8. Subtract 1. So x is 7. And then over here, we've got 3 plus y times 1, so that's 3 plus y equals 2 times 2 is 4. Subtract 3 from both sides, and you get y equals 1. Alright, so your midpoint would then be 7, 1. Good? Alright, so that's one way. Another way you could actually do this is by actually kind of taking a look at the graph here and plotting our points and just kind of figuring out where the next point would be. So what I mean by that is 1, 3. Here is the A. And then the midpoint is at 4, 2. 1, 2, 3, 4, 2. So that's the midpoint. So then we know the other point's got to be somewhere over here. So if you think about it, if you have to go down 1 over 3 to get to the midpoint, you'd have to go down 1, 3 more over to get to the other endpoint. which we'll call B. And if you look at the coordinates of that, that is 5, 6, 7, 1. So that is 7, 1 as well, which you'll notice matches our original one over there. Okay. Another way to do this, similar to what we just did there without a graph, is to try this and see if this makes sense. So you start with your original point, 1 and 3, and then you have to add an x value and a y value to come up with your midpoint, which is 4 and 2. Right? So you say 1 plus what gives me 4, and that would be 3 in this case, and then 3 plus what gives me 2, and that would be -1 in that case. So again, you would just take these numbers here and then add those to your midpoint. So add 3 to the 4 and we get 7, and that 2 minus 1 gives us the 1. So there is a third way to get your midpoint. And again, you'll notice all three of them give us the same correct answer. Alright? Okay, let's take a look at one last example, and then away we go. So we're going to use the midpoints to find the fourth vertex of the given parallelogram. Okay, and again, there's, just to kind of remind you, there's our midpoint formula. A couple ways you can do this. One way really is that the midpoints here, the midpoint of this line, the AC line, and the midpoint of BD are both right here, and they're both the same. So once you find the midpoint of this line, then we can use either any of the ways that we tried on that last example to find the other endpoint, because we'll know that the first endpoint and the midpoint, and then we can figure out what the other endpoint is. Okay, so let's find the midpoint of AC. So the midpoint of, let's use a different color. Midpoint of AC is, let's do -1 to -2, so -1 plus -2 over 2, and then 3 plus -1 over 2. So midpoint of AC, -1 and -2 is -3 halves, so we can just leave that. And then 3 plus -1 is 2. 2 divided by 2 is just 1. So there's our midpoint of AC. So we know this point right here is -3 halves, -3 halves, and 1. Okay? So what we can do with that is, again, you can put -1.5 if you didn't like -3 halves, but then we can just again say, okay, how do we get from 2, 4 to -3 halves and 1? So the last way that we did just on the last slide, we started with 2 and 4, our original endpoints, and then we are going to end up with our -3 halves. I'm going to turn that into -1.5 and 1, and I say, okay, what do I have to add or subtract to those to get to here? So let's see, difference between 2 and -1.5 is -3.5, and then 4 minus 3 gives us 1, right? So I really should have the line there instead of there. Let's fix that, get rid of that line. Right, so 2 minus 3.5 is -1.5, and 4 minus 3 is 1. So subtract another 3.5 from that, and subtract another 3 from that, and that should get us all the way to this endpoint here. So that is, let's see, -5, and then 1 minus 3 is -2. So our midpoint, sorry, not our midpoint, but our endpoint, which is D, should equal -5 and -2. Alright. One other way that you could try this out is to just figure, okay, to get from here to here, so to get from B to A would be the same thing as getting from C to D, since it's a parallelogram. So to get from here to here, to get from 2 to -1, And to get from 4 to 3, what do you have to do to 2 to get to negative 1? You got to subtract 3. To get from 4 to 3, you got to subtract 1. And again, bring these down, kind of like pretty much just like what we did over there. And then let's see, so we bring these down to negative 3, bring this negative 1 down, and we got to go negative 4 and 2. Okay, so to get from this point to that point, oh, I think I just did the midpoint thing. I think we only have to do that once. Sorry, let me back up. We got to get rid of all this. This is what we wanted. Sorry, this negative 3 and negative 1. So to get from this point to that point, we subtract 3 from the x and subtract 1 from the y. So we do the same thing to the c. So starting with c, which is negative 2, negative 1, we subtract 3 and subtract 1. And we get negative 5, negative 2, which is the same thing as that there. Okay, so again, as long as you can ignore that extra little flub up step there, then that should work just great for the midpoints. All right, if you have any questions, please feel free to ask. All right, thanks.